All right, today we are starting a unit on transformations. So we are not doing a specific chapter. All of the sections that we are going to cover are coming from different chapters. So today we're covering a section that we didn't do in chapter 3. Our objective today is going to be to identify and use translations. This lesson is titled Translations, but we're going to talk about transformations first. A transformation is an operation that maps or moves a figure onto a new figure. There are multiple ways that we can transform a figure. We can flip it. We can turn it. We can shrink or enlarge it. States again that these are all talked about in different chapters. So we are going to be doing all these different sections, even though we haven't gotten to those chapters yet. All right, today we are learning about translations. A translation is a transformation in which the image is created by sliding the original figure. When you hear translation, think slide. We are not turning the object. We are not flipping the object, and the object is not changing size. We are only sliding the object. All right, more vocab. When we are talking about transformations, we refer to the image. That is the new figure after a transformation. So the new figure is the image. The original figure is called the pre-image. The original is called the pre-image. The new one after a transformation is called the image. On these ones, you do not have to try to draw the diagrams for these. You just need to make sure you get the answers down. So we are deciding whether the red figure is a translation of the blue figure. So for it to be a translation, it means we simply slide it over, nothing else. So for A, do we think we could slide this blue one over to create the red one? Yes. All we're doing is moving it kind of diagonally. So yes. So we would say yes, this is a translation. On B, could we slide the blue one to make the red one? No, why not? It was turned, it was rotated. So no, it's not simply a translation. What about on C? Why not? It changed size. It's too small. So that means that it was a dilation.
Is that a vocab word? One of the vocab words?
Dilation will be a vocab word later this week. Questions on example 1? All right, example 2 is pretty similar. You have these ones on your page already. We are deciding if the white figure is a translation of the shaded figure. So on number 1, do we think that that is a translation? No, why not?
Because it flipped sides.
It flipped over. That's called a reflection. We'll learn about those later this week. So no, flipped over. What about on 2?
No.
Why not? It turned and it got stretched out. So that one's definitely not just a slide. What about on 3? 3 is yes. All we have to do is slide one and we can create the other one. Questions on example 2? Okay. Then we've got some notation to talk about. Whenever you see points A, B, C, etc., and points A prime, B prime, C prime. Looks like they have a little apostrophe on them. The points with the little tick mark are the points of the image, or the new points. As you've already heard me saying, we read this as A prime. Describing translations. To describe a translation, we start by looking at how a point gets from its original position to its new position. The same translation should be true for all of the points of that figure. So if we're moving one figure, we should be applying the same translation to all of its points. All right, so if you flip it over, I think we've got an example on the top of the back. We are wondering, how does point A travel to get to point A prime? So we see point A is down towards the bottom. It's at 4, -1. It is moving to point A prime, which is at 1, 4. So to describe the translation, we want to tell how it gets from A to A prime. So we could count and see that it moves left 3 units and up 5 units. And we can get that just by counting. We move left 1, 2, 3 units. We move up 1, 2, 3, 4, 5 units. A to A prime. Assuming that we are correct, the same movement should be true for point B going to B prime. So again, if we start at B and we go left 3, 1, 2, 3, and up 5, 1, 2, 3, 4, 5, we end up at B prime. So this is describing translations just using words: left, right, up, down. On we go. Example 3, describe the translation of the figure. So remember, we start at either C or D. It doesn't really matter which one. And we figure out how we would have to move in order to get to C prime or D prime. So what do you want to do, C or D? D is the first one I heard, so that's the one we'll go with. If you want to do point C to C prime, your answer should be the exact same. So we're starting here at D. We are trying to get to D prime. Am I going to have to go left or right? Right, how many spaces? Right 3 spaces, and then up or down? Down 4 spaces. So we would say that we have to move right 3 units.
Are we writing this under one?
Yes, I would write this underneath the graph.
Put R3U.
No, write out the word right. We're going right 3 units and down 4 units. If we want to double check ourselves, we can do it with the other point. So if I start at point C and I go right 3 units and down 4 units, I should end up at C prime. So we go left 5. We're starting to get from Z to Z prime. Left 5 and then up or down? Down how many? 2. Left 5 units, down 2 units. So if we're not sure, we think that we got it right with Z's, but we're not entirely sure, we can go to our X's and check. If I go left 5 and down 2, do I end up at X prime? Left 5, down 2. Yes, I do. So that still works. It should also be true for Y. If I go left 5, down 2, I should end up at Y prime. I do, so that means I must have gotten it correct.
So we only have to do one.
All right, more notes. This time we're talking about coordinate notation. So we've been using the words right, left, up, down to describe a translation, but we can also use coordinate notation. When we move right, which value, x or y, is changing? X is changing. What about when we move left? X is still changing. What about up and down? If we're moving up and down, y is going to be changing. So think about your axes from Algebra 1. If you're moving left and right, that's along the x-axis. If you're moving up and down, that's along the y-axis. So let's be a little more specific. When you move right, you are adding to the x value. When you move left, you are subtracting from the x value. When you move up, you are adding to the y value. And when you move down, you are subtracting from the y value. Explaining the notation. So this is using coordinate notation. This is what it's going to look like. X comma y in parentheses with an arrow. That's how it will always start. So we're saying we're starting at the point x comma y. We are sliding it to, in this case, their example is x plus 1 comma y plus 5. So x comma y represents the coordinates of the original figure. The arrow represents the slide. The x plus 1 comma y plus 5 means we add 1 to the x value, sliding right, and add 5 to the y value, sliding up. On example 4, we are describing the translation using coordinate notation. We are going to use the arrows that they gave us, so we are going to say that the solid triangle here is our pre-image, and we are ending up at the dotted line triangle. That'll be considered our image. Anytime we use coordinate notation, it always starts off the same. X comma y with an arrow. Anytime you see coordinate notation, that's how it will begin. Then we have to say how the x value is changing. So if we look at where we start, do we go to the left or the right? To the right. And if we're moving to the right, are we going to add or subtract? Add. And how many units are we moving right? 1, 2, 3, 4, 5, 6, 7. So x plus 7, comma, y, being up or down? Up, so are we adding or subtracting? Adding how many units? 1, 2. Okay, so we went to the right 7, up 2, x plus 7, y plus 2. All right, on number 7. Again, coordinate notation always starts the same. X comma y with an arrow. Then we have to say how it's changing. So again, we start at the solid figure. We're moving towards the dotted line figure. Am I moving left or right? Left. If I'm moving left, am I going to add or subtract? Subtract. So x minus how many units? 4 units, comma, y. Then are we going up or down? Down, which means we are going to subtract how many units? 4. So if we want to the left 4 and down 4, it's going to be x minus 4, comma, y minus 4. All right, our next set of examples is actually a matching section. So we are going to match the description to its diagram. These are a little hard to see on the board, but they are printed on your handout, so that should make it easier. So we have to figure out which of these diagrams shows that we moved 4 units to the right and 2 units down. Remember that we always have to start with the plain letter A, or B, or C. We do not start with the primes.
On 7 is B.
So on 7, we think it could be B. So we can check it. If we start at B and go to B prime, if we move 4 units to the right and then 2 units down, did we end up at B prime? Yes. So for that top one, it would match up with letter B. The next one, 3 units to the right and 2 units up. A, so we can check it. 3 units to the right, 2 units up. I would agree. By default, number 9 has to be C, but we can check it to be sure. 2 units to the left and 3 units down. 2 units left, 3 units down works. On example 6, we are finding the image of the points using the translation x comma y goes to x minus 2, y plus 4. If this is our translation, what's happening to the point 3 or the number 3 in part A? We're going to subtract how much? 2. It says x minus 2. 3 is our x coordinate. So that means this is going to become 3 minus 2, comma, what's happening to the negative 2? We're going to add 4. So what is 3 minus 2? 1. And what is negative 2 plus 4? 2. So this would be our image. The point 1 comma 2. All we did was plug in our x and our y into the translation that they gave us in coordinate notation. We do the same thing on B. This is going to go to, what's my x value? Negative 1 minus 2, comma, what's my y value? 4 plus 4. So on part B, what is my new point? Keon, what is it? Negative 3, comma, 8. On part C, we're using the same translation from above. What's my x value? Negative 3 minus 2, comma, what's my y value? Negative 4 plus 4. What is negative 3 minus 2? What is negative 3 minus 2? Negative 5. And negative 4 plus 4 is 0. Find the coordinates of x prime, y prime, z prime using the translation. X, y goes to x plus 4, y minus 2. And they gave us all of our points for x, y, and z. So this is going to be very similar to the last one. They've just given us names for all of these points, instead of splitting it up and acting like they're separate questions. So in order to find x prime, I need to take 2 and 3 and plug them into x and y of my coordinate notation. Does anybody know where the point x prime would be? We can keep writing out more steps if we're not sure yet. So to find the point x prime, we need to take 2 comma 3 and translate it. What's my x value? 2. We're going to add 4 to it. Comma, what's my y value? 3, and we would subtract 2 from it. What is 2 plus 4? 6. And what is 3 minus 2? 1. So that is where x prime would be. Then we have to do y prime. Y starts at 3 comma negative 4. We are going to plug those points into the coordinate notation rule that we were given. What's my x value? So we have 3 plus 4 comma my y value. Negative 4 minus 2. What is 3 plus 4? 7, and negative 4 minus 2. You lose 4, you lose 2 more. Negative 6. And finally, we have to do z prime. So z starts at negative 3, 5. Again, my x value is negative 3. We add 4, and my y value is 5. We subtract 2. What is negative 3 plus 4? 1, comma, 5 minus 2 is 3. So in order to find x prime, y prime, z prime, we use the same rule. We started with x, y, and z. All right, that's the end of today's notes for translation.